Assalamualaikum warahmatullahi wabarakatuh. So today will present about ITT585 group project with the title Secure Enterprise Network Infrastructure for Sunday Group Ipoh branch. Here is our team members. First one is Mohamad Hafiz Izzuddin bin Elias. And next me myself, Athirah Binti Mohamad Rosidi. Next Mohamad Alif Hakimi bin Mohamad Ali. And last one Mohamad Hanif Najmi bin Mohamad Hazrol. This is our project background. Sunday Group is establishing a new branch in Ipoh. A secure enterprise network is required to support daily business operation. The network consists of 3 departments, which is management, information technology, finance. Public services like HTTP, email and FTP must be accessible while protecting internal resources. And last one, the network is designed and implemented using Cisco Packet Tracer. Here is our project objective. First one is to design a secure enterprise network infrastructure. Next, to implement multiple network security features like VLAN segmentation, SA firewall, access control list, static NAT, DMZ, AAA authentication, HSRP redundancy, and wireless security. And last one, we want to test and verify that authorized traffic is allowed and unauthorized traffic is blocked. Next, I will pass to the Mohamad Hanif to present.
Thank you, presenter one, Athirah. So I will going to continue, which is next our problem statement. So what's the problem? First is a flat network. We allow unrestricted communication between departments. And next is no network segmentation increase the risk of lateral movement. Public server hosts inside the internet network are vulnerable to external attack. And next, a weak access control may lead to unauthorized access and data breach. Lastly, lack of redundancy might cause network downtime if a device fails. So this is our network requirement. They have to type for business and operation requirement is reliable wired and wireless connectivity, high network availability, scalability for future expansion, easy network management, secure to the organizational resources. And next, our network requirement, they have a firewall protection, VLAN segmentation, inter-VLAN ACL, DMZ for public servers, static NAT, AAA authentication, HSRP redundancy, WPA2 wireless security, and lastly is our unused port hardening. So next, which is our proposed network topology. As you can see from here, is our main, and we contribute to the firewall and the tunnel. And lastly, we divide into our VLAN segmentation for 3 departments. So next, our candidate, which is Mohamad Hakimi, will continue the presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Alif Hakimi bin Mohamad Ali. I will demonstrate the VLAN segmentation, DMZ server and AAA login. All configuration are already complete, so I will only use verification command and connectivity testing. Okay, for our VLAN layout, we have VLAN 10 for management, VLAN 20 for IT department, and VLAN 30 for finance department. We also have VLAN 99 is for DMZ server. Multi-layer switch provide the gateway and perform layer 3 routing for VLAN 10, 20 and 30. VLAN 99 use ASA firewall as its gateway because the public facing server must be separated from the internal departments. Okay, I will verify the VLAN pada multi-layer switch. I will show VLAN brief. This command confirm that VLAN 10, 20 and 30 have already been created. And then show IP interface brief. This interface show the default gateway for the management, IT and finance department. Multi-layer switch use this interface to perform layer 3 routing, and then show interface trunk. The trunk link carry multiple VLAN between the multi-layer switch and access switches. VLAN tagging keep traffic associated with the correct department, and then I will demonstrate the same VLAN communication. From this PC, I will try to ping this PC in same VLAN. The IP address is 10.10.10.22. It can connect to each other. Then the management gateway is successful. It shows that both PC belong to VLAN 10 and it can reach its gateway. And then I will demonstrate the VLAN isolation. From this VLAN I will try to ping to the IT department. This IP is 10.10.20.21. destination host is unreachable. And then to the finance department, 10.10.30.31. It also unreachable. These pings fail because access control list block direct communication between management, IT, and finance. Although multi-layer switch can perform inter-VLAN routing, the SCL prevents unauthorized communication and reduce lateral movement between departments. And then I will return to multi-layer switch and run show access list. Okay, these are existing SCLs used to isolate the three departments. Okay, I will demonstrate the DMZ server. From this management PC, I will ping the HTTP server. This HTTP server with IP 10.10.99.20. Okay, it's work. Auto direct communication between department is blocked. Authorized user can still access the approved service in the DMZ. Next, I will demonstrate the AAA. In this demonstration, we will mainly show authentication by confirming that multi-layer switch require valid username and password. For this username, admin, and then admin123. The successful login confirm that AAA authentication is working. A user cannot access the multi-layer switch without entering a valid username and password. Our working topology use local AAA. This means the username and password are stored directly on multi-layer switch 0 and this multi-layer switch 1. Then I will explain the AAA server. The AAA server is located in a management VLAN 10. Its IP address is 10.10.10.50 and its gateway is 10.10.10.1. In a production network, this server called centrally authenticated network administration using radius or TLC/SCS+. However, due to packet tracer limitation, our current topology use local AAA. Therefore, multi-layer switch check the username and password stored directly on the device instead of sending them to this server. I will test connection from multi-layer switch. The successful ping confirmed that multi-layer switch can communicate with the AAA server. However, it only confirms connectivity. The server is not currently validating the MLS login. That's all for me. I will pass this to Hafiz.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Izzuddin bin Elias, and now I will continue the presentation. So previously, my friends, Mohamad Alif has been present the right hand side of this topology, and now I will represent on the left hand side of this topology. So I will explain the three main network components in our topology, the consists of the internal network, the MZ, and the public network. So the internal network consists of the management, IT, and finance department. This network contains the important company user and resources, so they must be prevented from the external access. And then the second one is a DMZ. So the DMZ is located between the internal network and the external network, which containing the public facing email, HTTP, and FTP server. And the last one is the public network that represents the internet. In our topology, we have the router SP and the home router that represent as the user. So let's move on the ASA firewall. So we have done several implementation on this ASA firewall. The first one is the security level. So the security level is used to divide the trusted traffic on these three network components. So, okay, for example, for the internal network, we have security level of 100, which represent the most trusted traffic on this network. And then for the DMZ, we have the security level of 50, and the last one is the outside network that has the security level of 0. So the second implementation is NAT, or the network address translation. So NAT is used to make sure the external user can access the MZ to use their services such as HTTPS or HTTP. Okay, and then the third one, we have implement a lot of SS rule in this firewall. This is to make sure the rule, the security, and the policy has been implemented in the three main component of network. So yeah, that's all for the SL firewall. So let's move on the HSRP. So HSRP is stand for Hot Swap Routing Protocol. So in this topology, we have two router for HSRP. So one for the active router and the second one is a standby router. As you can see here, the first router is active on the state active, and the second one on the standby state. So the function of this HSRP is when one router is unavailable, so the standby one will be the active router, and the internet or connectivity for this company and the outside network is 24/7, can be accessed anywhere, anytime. So as you can see here, we have the router ISP that act as the internet. So our group thinks that this is a good practice to use the router ISP instead of directly connect the serial one into the internet cloud here, because most of in real world, most of the company or the university itself will connect to the ISP router first before going to the internet, right? And then okay, so we move on to the VPN, remote user VPN. So the home router and the PC home represent a remote employee or external branch. So in the real enterprise network, the remote user will connect to the public interface of the ASA using an encrypted tunnel. And then the VPN protect data while it travels across the public internet. However, due to Cisco packet tracer limitation, a complete remote access VPN could not be fully implemented in this prototype, because there are some limitations that we encountered when we want to implement the VPN on this topology. So therefore, we just represent as a conceptual ideas in our topology. So the firewall still blocks direct external access, but if the PC home have the VPN access to this firewall, so it can access to the internal network. So yeah, that's all from me. Thank you.
So we are going to the end of this, which is conclusion. So this project is successfully designed and implement a secure enterprise network. So implemented the key security features like VLAN, firewall, ACL, DMZ, NAT, AAA, HSRP, and WPA2. The testing confirmed that authorized access is allowed while the unauthorized access is blocked. So the proposed network is secure, reliable, and scalable. So that's all from us. Thank you. Bye.